But how many places? This line crosses it at 2 spots. So that parabola doesn't have an inverse function. This passes the horizontal line test because each horizontal line will only hit the graph once. Okay? So now we get to the issue of sines, and that is going to give us some trouble. Okay. Let's also talk a little bit about domain and range. Okay. If I have sine of something, suppose I have sine of, I don't know, pi over 3 is equal to root 3 over 2, right? Now look. The original of this looks like sine of x is equal to y. So this number here represents the x value, which represents the domain. Okay? So the numbers that go in there are values of the domain. And if you look at a sine function, right, how it just goes on and on and on forever, the domain of a sine function is all real numbers, right? This is the range. The values that you get is the range. And if we look at a sine function, what's the range of a sine function? It goes up to 1 and down to -1. Okay? So just clarifying what parts of this stand for the domain and what parts stand for the range. Okay, so now let's go to inverse functions. We just said in order for a function to have an inverse function, it should pass the horizontal line test. Well, when it comes to a sine graph, man, if I draw a horizontal line, it passes the graph at an infinite number of points. So what does it mean? Can I never find the inverse of a sine function? Of course not. What we do is we say, you know what? Let's just take a little tiny itty bitty part of the sine function. Namely, let's just take this portion of the sine function. Does that portion satisfy the horizontal line test? It does. So now when I find the inverse of the sine function, it's only for that portion. What I do, what this process is
A question.
Yeah.
How do you decide like which portion to take?
So we make it as close to the origin as we can. It's always going to be this for the sine. Mathematicians have already ruled on that. Yeah. So what this is called is we are restricting the domain. And this is the restricted function. And it only exists on the interval -pi/2 to pi/2. So remember how here, when we had sine of pi/3, I said the domain could be anything? For the restricted function, the domain is only from -pi/2 to pi/2. So what I'm doing is for f of x, I'm restricting the domain from negative to positive pi/2. And then the range, right, is still from -1 to 1. That means none of the other parts of the sine are even like gonna qualify for anything we're gonna do here. Now, when I then find the inverse of this function, okay, what happens is this. First of all, the inverse sine function has the symbol sine to the -1 of x or arc sine of x. They're synonyms. Greeks called it one thing and then we called it something else, okay? Okay, what happens to the inverse sine of x is, remember how in Algebra 2 when we were looking for inverses, we first said switch x and y? When we switch x and y, we also switch domain and range. So now everything that was on the x-axis goes on the y-axis, and everything that was on the y-axis goes on the x. So look at what happens. Negative pi over 2 was here, and pi over 2 was here. Now look at where they are. They're on the y-axis. Now, we're not going to graph inverse sine functions here, but look at what we are going to do. If you go back up here, for inverse sine of x, the domain becomes the range. And the range becomes the domain. Okay, so what does that mean? Okay, what is inverse sine of x? If I had up there sine of pi over 3 is equal to root 3 over 2, for inverse sine, this is how it looks. Now we're going to go in the opposite direction. When I say inverse sine of root 3 over 2, you see how it switched places? What I'm asking you is, what is an angle for which the sine is root 3 over 2? And you have to find the angle, which in this case is pi over 3. Okay, so for what angle is the sine 1/2? For what angle is the cosine -1? So now look at what happens. This stuff in here now, that's the domain of the inverse sine, and it can only take on values of -1 to 1. And this is the range. It can only take on values from negative pi over 2 to pi over 2. That means two things. Yeah.
Is the range and domain always going to be the same?
For inverse sine?
For inverse sine, unless you have like a, what's it called?
Yeah, we're not even going to have those. We don't. There's no such thing. This is it.
Okay.
Yeah. So that means the number in here cannot be less than -1 and it can't be greater than 1. But the other part is more interesting. Look at this. The range is from negative to positive pi over 2. Let's take a look at what that means. This is the unit circle. Remember the unit circle, guys? Okay. All right. This is 0. This is pi over 2. And where is negative pi over 2? Right here. Okay, so if I say the range is from negative pi over 2 to pi over 2, what I mean is only angles in this region are allowed for inverse sine. So let's put in some more angles. This is pi over 4, pi over 6, pi over 3, negative pi over 6, negative pi over 4, negative pi over 3. And so now, I'll just break it down for you. If you're asked an inverse sine question, how many angles are on this unit circle right now? 9. Your answer can only be one of these 9 angles. That's it. Nothing else. You can't have 7 pi over 4. Even though 7 pi over 4 lies in that quadrant, it's not part of your allowable angles, so you can't use it. Okay, so now let's do this one. A is asking us inverse sine of root 2 over 2. Someone's looking for the angle, the sine of which is root 2 over 2. What angle gives you sine root 2 over 2? Eliana?
45 degrees or pi over 4.
Pi over 4 is right. And that's it. Okay? So look, sine of 3 pi over 4 is also 45 degrees. But that's not in my domain. I mean, that's not in my range, so I can't use it. It's not in my restricted domain, right? Look here. Look at where 3 pi over 4 is. It's right there. You see how it's not even in my like domain to use. So it's unusable. It doesn't exist to me. Yarden, did you have a question?
Yeah, I was just wondering, are you basically just asking yourself, like for A on the, asking when the sine equals root 2 over 2?
It's exactly what you're asking. And then here, when does sine equal negative 2 pi? Now that's a trick question. Because remember what we said? The number in here can only be from negative 1 to 1. How much is negative 2 pi? It's negative 6.28. It's out of the domain. Not possible. Okay? All right. Let's do one more.
Miss Malik,
Yep.
how do you know when you're looking for the domain or you're looking for the range?
Okay, so for inverse sine, okay, so the number that's in here, right? The number that's in this position is always the domain. If this is an inverse sine, then it's the domain of the inverse sine. But if it's, let's say, like sine of pi over 4, then this stands for the domain of the regular sine. You see that?
So then why did you say something about going from negative 1 to 1 if we're only looking at the range, which is pi over 2 to negative pi over 2?
In here, I said this is the domain for that problem. And I said the domain can only be from negative 1 to 1, the domain of the inverse sine.
I get it, yeah.
It's
counterintuitive. I totally get it. It takes a while. Okay.
Mrs. Malik, so
Yeah.
on that question, where did the 3 pi over 4 come from?
Oh, I just made it up. I said, because here we were looking for an angle, like sine of what gives you root 2 over 2, right? Someone can tell me, hey, Miss Malikian, sine of 3 pi over 4 is also root 2 over 2, so why can't I write that? Right? But the answer is it's not part of our angles. So cosine and tangent are exactly similar, okay? For cosine too, look, this is what the cosine looks like. We have to pick a portion of the cosine that will satisfy the horizontal line test. I will pass the horizontal line test. So, well, what's a good portion? Well, this is a good portion from here to here, right? That's what we pick. You could have could we have done that? I mean, I guess mathematicians could have done that, but that's so far away from the origin. We want to stay close to the origin. So in this case, this goes from 0 to pi. Okay? What you have to know is that for inverse cosine, we don't go from negative to positive pi over 2. We go from 0 to pi. Here. So when I draw the unit circle, it basically just comes down to this. When I draw the unit circle, I want the values from 0 to pi. Okay? What angles exist in that space? Pi over 2. And then this is pi over 6, pi over 4, pi over 3, and so on, right? This is 2 pi over 3, 3 pi over 4, and then 5 pi over 6. So for cosine, inverse cosine, it's only those 9 angles that are possible as an answer for inverse cosine questions, right? So let's take a look here. Cosine of what is 1, right? For what angle is cosine 1? What do you guys think? It's one of those 9. Max?
Never mind. 0?
0. For 0, the coordinates are 0, 1, so it's 0 degrees or 0 radian. Okay.
So,
yep.
when it's asking for like a question like this, and you're given like the inverse and then like a number, you're looking for y basically.
Yeah, the angle. Okay. Cosine of what is negative root 3 over 2? Where is cosine root 3? Matthew?
Negative 5 or 6.
Okay, negative pi over 6, yes, at negative pi over 6, it is negative root 3 over 2. But negative pi over 6 is here. Is that part of my 9 angles? No. So let's find another one, and that is 5 pi over 6 right there. Right? So 5 pi over 6. Okay, so you know what, Matthew? I am so thankful that you said pi over 6. Yes, because that's what I want. I want students to, to go to those regions so we can figure out why one works and one doesn't work. Okay, so negative pi over 6 would have been here, but it's not in my restricted domain. That's why I can't use that. Okay.
So
what?
Why didn't you use, how come you didn't use pi over 6?
Good question. Because at pi over 6, the cosine is positive root 3 over 2. Okay, so the way these are going to work is we're basically going to have 2 quadrants for each one. Okay, one quadrant will be for the positive values and one quadrant will be for the negative values. Okay, and then here, cosine of negative 2, it's not possible because that's out of the domain. Okay, all right.
Should we write no solution or not possible?
It really doesn't matter. Okay. Okay, tangent. Yep.
Why is it impossible?
Because the number in here can only be from negative to positive 1.
Wait, what? Sorry, I cut out.
This number can only be between negative and positive 1. Okay, now for the tangent, you can see it's like pretty, easy to figure out that if you just take that one arm, that satisfies the horizontal line test. So my restricted domain is again from negative pi over 2 to pi over 2. So it looks like this. Similar to the sine, it goes from negative pi over 2 to pi over 2 with all the angles in between. The difference is tangent is not defined at negative and positive pi over 2, so we just throw those away. So it's really the same as sine except with 2 less angles. Now there are only 7 possibilities. Okay? But exactly. But for the tangent only, if I have inverse tangent of x equals y, this can be any number. Okay. All right. So tangent of what is equal to 1? Well, pi over 4. Okay. Yeah, oh, pi over 3, yes. And then here, for what angle is the inverse tangent, for what angle is tangent root 3 over 3? That happens to be pi over 6. Okay. All right. Yep.
Is there no range? Because I see in the inverse tangent graph, there aren't like line segments There's no dots. There's just arrows that come off rows.
Yeah, that's why I said here it could take on any value. Because you see how like the range used to be all real numbers for tangent? Now the domain of the inverse tangent is all real numbers. Okay. So what I have here.
I get that answer though for B.
For B, so the tangent of pi over 6. So here, if we have pi over 6, right? What does that look like? You have 1/2 on that side and root 3 over 2 here, right? So tangent of pi over 6 is 1/2 over root 3 over 2. So that's 1 over root 3, but the rationalized form is root 3 over 3. Was that your question?
Not quite. I still understand how to get pi over 6 to start with.
So I basically work backwards. I say to myself, okay, for what angle, like tangent of what is 1 over root 3 or root 3 over 3? So, okay, so were you able to get this one? Did that one make sense, part A?
Not so much.
Okay, so how do we get tangent? It's sine over cosine, right? Or it's the opposite over the adjacent. So then you have to say for what angle is the opposite over adjacent going to have a ratio of 1? And that's for pi over 4.
That makes sense.
Yeah.
Never mind, I get it now.
Okay. So these are like just different charts that summarize. This chart is from another book, which I find kind of helpful. It tells you like what quadrants each of the, inverse sine, inverse tangent live in or exist in. I also find that like these, when you draw them like this, those are also helpful for students, right? Like these things here. Okay, so let's apply some of this. So look at example 4. You want to find the exact value of these. Look at this first problem. It says sine of arc sine of something. Okay, what's happening here is the sine and the arc sine are inverses of each other. In a sense, they make each other cancel out. They make each other go away. So really, when you have the same function but inverse of each other, you can just say the answer is 1/2. The only thing you have to be careful is that make sure it's in the domain. Okay? So, it would be like sine of arc sine of 2, and then you say, oh, it can't be greater than 1. Yeah. Okay. Yeah. Okay. Take a look at this one. Here we have a little PEMDAS action happening. So here I have inverse tangent of 1, right? I want to evaluate that first. Inverse tangent of 1, we just said before, was pi over 4. Here I have inverse sine of 1. And so for what angle is sine 1? That's pi over 2. So what I do now is I say this is equal to sine of pi over 4 minus pi over 2. And then this is sine of, when I do the common denominator there, that's negative pi over 4. And then that's from like section 4.1 to, or 3, What's sine at negative pi over 4? It's negative 1 over root 2. Okay, Eliana?
Just a general question. How do you know when to graph more than one line? Like, when you're graphing like a tangent line, should we repeat it and do like as many periods as possible?
No, just one. Okay. Yeah. Okay, here, take a look at what we're gonna do. We're going to, okay, so you have sine of inverse cosine, like totally different functions of 4 over 5, right? So here's what we're going to do. First, you draw a triangle. Okay, you draw a right triangle and you label them. So we're going to start from this part here. I'm going to draw a right triangle. So look at what that red part is telling me. It's telling me that there is an angle, the cosine of which is 4 over 5. So if this is the angle, how do you make it so that cosine is 4 over 5? Like this, right? Adjacent over hypotenuse. Now, can we find the missing value x, the missing side? Pythagorean theorem, and then somebody goes, wait a minute, is that a 3, 4, 5 triangle? Oh my God, it is, right? So you do Pythagorean theorem, you find that side. Now, on the outside, look at what you have, sine of that angle. So you say, okay, sine of that angle is 3 over 5, okay? Now, let me do another one before you guys ask questions because we're almost out of time, but I can do this super quickly. Look, I have arc sine of x, okay? I draw an angle. This is an angle, the sine of which is x or x over 1. So opposite over hypotenuse is x over 1. Now, this bottom side b, if I do the Pythagorean theorem, okay, I subtract x squared. B squared is equal to 1 minus x squared. Take a square root. B is 1 minus x squared. Okay? So this is 1 minus x squared. So now, if I want the cosine, right? Because that's what it says on the outside. Cosine of theta is adjacent over hypotenuse. So that's what it is. Okay? And we'll leave it here. I do have a recording of this.